Hey, thanks for joining my session on serverless architecture patterns for securing the unseen. I'm really excited to speak about this topic today at this conference. And there's such a crucial topic, I believe, at our day and time where serverless has really taken off from a cloud perspective. And I'm really excited to share about some of the patterns and things that we can do to secure it. My name is Javis Abraham, and I work as a cloud security architect at Asurion. I would like to start off with this one picture. A lot of times when you look at a picture, you kind of think about what does it represent? When you think about this, you think about a house, you think about dreams, visions, goals, maybe aspirations for someone who wants to build something or plan for something for their future. But most importantly, we think about this picture, we see the importance of it is in that person. And of course, as much as we would like to look at this picture and saying, man, that's a beautiful house or whatnot, the ultimate thing that we look at security perspective is the person that we're trying to protect. And when we think about serverless, a lot of times people jump right into and say, hey, I want to start securing it. What architectures do I implement? How do I protect it? What are some controls I need to have? What are some areas that I need to look at? But a lot of times they miss out. What are they really trying to protect? What are we really trying to do? So that question, I believe, is very central to this topic of securing the unseen. Because a lot of times what happens is we get caught up into our day-to-day and doing the operational aspects of securing something, but forget about the plumbing work, the deep dives, the understanding of what am I really trying to protect. So this picture just serves as an image of what we want to think about when we're thinking about securing serverless, as what is the crucial nature of what we're trying to protect, the data. That the data is what is crucial that we're trying to protect in this scenario. So we're going to go through this agenda quickly on some of these topics that are going to be covered here. The life cycle of the data, obviously we've talked about the importance of what we're trying to protect, and accessing the data. How does somebody get into the accessing the data? And we're going to talk about certain threat vectors when we're talking about serverless. Again, serverless has changed the dynamics of security, where traditional security mindset it gets really hard to justify in applying the same mindset to a serverless architecture. And so what we would like to do is I'd like to talk about is how do you change your mindset when you're dealing with serverless technologies? And then we'll talk about some design principles. What are some things to be considering when you are starting to architect serverless architectures, and then some applications, some practical real world applications. And we'll use certain specific areas that we'll be talking about. And so jumping right into it, when you think about the life cycle, when you think about a data, you think about the aspects of creation. Somebody creates data, whether it could be time-sensitive data, like a newscast or a tweet or whatever it may be. It's a very time-sensitive information. And then you also think about like the data types. The data types could be, something that's publicly available or something that's private, like maybe there's stock markets. And again, things that are happening in millisecond time frame. And then, of course, the damage it can produce. And that is crucial as well, is when you think about data, not only it could be time sensitive, it could also be classified with certain type of data classification, but also what type of damage can it produce. So you have in this slide, the creation of the data by various entities. And then you have the storage of the data. It could be in a cloud environment. It could be in your data center. It could be anywhere for that matter. And then the consumption of the data, whether it's the users, whether it's some artifact or archival, whatever it may be, how do you consume that data and make it available? And when we follow along, and from the perspective of the life cycle, we have to kind of switch gears a little bit and talk about, so how do I access data? Not only does my life cycle matter, meaning that how does the data flow through my system, but how do I make it available? That consumption that we talked about. So you have these various different people that we're talking about, right? You got producers, you got protection boundaries, you got consumers, and then you've got, of course, perpetrators. And when you think about in that perspective, the producers could be anyone from the Internet of Things, where data is accessible to the end user. And of course, well, what are some protection boundaries that we can think about, like privileges and authentication, authorization, logging? What about technical debt? A lot of times people think about technical debt as something that's behind the scenes, but it's real challenge sometimes if you don't think about it ahead of time. And then the consumers, people we love, people we want to share it with, people that we want to share the data with, and of course the perpetrators. And that's always there. You saw the slide when it came up. It was already there because the perpetrators are always there. Whether you have data or not, they're going to constantly be looking to infiltrate and try to access data that is not allowed for them. And when we think about that perspective, and we think about the context of serverless, how do you think about serverless and the threat it produces? I mean, this picture, if you look at it, is an interesting representation, and many of you may have seen it. The picture talks about an iceberg. You think about an iceberg as something that's visible, something that's from the Titanic, or something that exists. But a lot of times what people don't realize is that there's a massive amount of ice that's underneath that's invisible. And when we talk about serverless, the data is a lot of times the threat is invisible to the user. When you take data and pass it on to a public cloud provider, a lot of times they are accountable for how they manage your protection of your data and how they store it. But ultimately, it's invisible to you for a lot of the aspects. How does the data get transferred? How does the data get stored? How does the data physically? How does the data get moved from one region to another? A lot of these different constructs that we talk about from a public provider perspective are invisible to the user. In a data center, I could walk in and look at it and say, here are my hard disks, here are my EMC drives. But in a cloud system, you don't have guarantee of which data resides where from a regional perspective. So it could be in one data center versus the other. So when you think about that type of a threat vector, we've seen really the revolution of cloud from an infrastructure as a service to function as a service, from monolith applications to microservices, and now again to serverless. And we've really seen the evolution of cloud technologies in that level. And people may think that why do people really go into serverless? When we talk about protection, but why is the real demand for serverless? There's many we can talk about. Today just touch point on a few. There's no infrastructure to manage. You don't have to patch. You don't have to worry about maintaining your infrastructure, making sure that you're networking and cabling and all of those things. And there's nothing to manage. And you don't have to do a lot of the work that is done to get the server ready for you. And then, of course, to be able to quickly spin up a function to be able to do certain type of work, a small volume of work, and being able to execute based on some of the requirements that you give it. Again, serverless gives a lot of benefits for a lot of the users and cost. You pay for what you use in a very, very small millisecond way. And so again, cost is a big driver for serverless, and the ease of deployment, where you can deploy in multiple decentralized methods, and you're not having this massive monolithic application. So serverless definitely is a big driver in that sense. But then you think about the security aspects of it. The attack landscape really has changed with serverless. Thinking about application weakness, you think about an application that somebody writes and somebody puts in the cloud, they could have the illusion that since I put it in the cloud, it's secure. Or because it's serverless and it gets very small ephemeral time instances, that it could be secure. And we're going to see a demo briefly on serverless is not inherently secure. It's how you secure it is what matters. And then, of course, IoT brings the data to the end users. Again, there's a different threat factor that we can talk about. And then when we think about serverless and security, just because it's an ephemeral system, that it only lives for milliseconds or a minute or 5 minutes, doesn't mean that it's inherently secure. And we're going to look at a simple example. In this example, if you see, there's lambdashell.com is just an open website that anybody can go in, and they give you a shell into a Lambda function. This is a real Lambda function in Amazon. And in this example, as you're watching, it's a regular Unix kernel. If you see that, it's got a shell, it's got df-k, it's got different values, it's got the index.js file that's there, it's got the root file system. It has all of these regular entities that you would expect in any Unix machine. Now, in this example, this person has given a shell access into a Lambda function. Now, when I do an environment variable in that server, I see a bunch of different environment variables, just as you would expect. in any system. In this case, I'm interested in certain things. I mean, which region I'm running in. I'm running in US West 1 in California. What is the access key that I'm going to be interested in? There's a access secret key and multiple other things. And here, all I'm doing is I'm constructing basically a method to access this infrastructure or this cloud environment from my laptop, from my personal laptop. So all I'm doing here is capturing the access key, the secret key, and the token. And so basically what I'm going to be doing here is that constructing these three elements that Amazon requires for me to be able to connect to my cloud environment from my laptop that's outside of a console or on a company's cloud account. So here I'm just exported the access key, I exported the secret key, and the token that is required for this attack. And once I do these three different entities, at this point, I have access to that person's cloud environment. So here I'm doing a simple get caller identity. It tells me that I'm in the Lambda basic execution role. Now, roles are super important in the cloud. And depending on the size of the role, I can get lateral movement. I'll be able to do lateral movement. In this case, I have access to do a very few amount of things, creating a log group, log events, log stream. Again, very, very minimalistic type role, which is good. But even with this, there are certain things I can do. So I can try to list roles. Of course, that's denied because it's a very restrictive type of role. And then also, I'm going to try to do certain other functions like creating a log group. And now someone may say that, well, those are very restrictive functions or controls or roles that are given permissions to. But ultimately, what I can potentially do with just this minimalistic permission is I can still create a log group. I can create a log stream, and then I can start publishing events to that stream. If you think about it, even in the sense in this example where this was, it's a shell that I have access from this website. I'm able to get into that person's account. I'm able to generate log events, and then I'm able to potentially kind of spike up their bill, in a sense where I can start sending multiple log events. I can automate it. Again, I get the token for an hour, which means that I can overwhelm their system with logs that are meaningless, which are just going to just spike up their bill. Again, this is a very simple example. This person has given access for people to be able to do that in the sense that he's opened it up for the world so that people can get a feel for how secure it is and different areas, and even has a bug bounty program in that website. But the important aspect here to capture is that serverless, by the term, just because it's ephemeral, doesn't mean that you cannot, that it doesn't need to be secure. So that is the important aspect of this demo. And when jumping into the next slide, we're going to look at some design principles. When you think about threat modeling, you want to think about from low to high risk data. What is my data movement in my architecture, and how does that movement affect how I need to secure it? And we're going to look at a couple of data maps, and it'll hopefully tie all this together. And that is crucial because a lot of times what people do is that they say, hey, I want to secure the entry point. I want to secure the backend storage, but then the data can move inside because it's inside my network. And they don't account for things like insider attacks or data leakage or accidental data exposure, things like that. So, and there are some very core principles that we have to think about when we're dealing with serverless. You have to think about in the sense of access sharing, making sure that you don't have much broader access than what is needed. In the previous example, we saw it was just a Lambda execution role, which is a very minimalistic access. And if somebody gives admin role, now that is a real risk. Why? Because somebody can get in, they can get access to that environment, and they'll be admin from their laptop, and now they can pretty much do what they want to do in the other person's account, including take over. So that is a very challenging thing that can happen. And so as we look into some of these areas, you think about things like anomaly detection in the sense of what is normal? What is a normal flow of my data? The data that I'm trying to secure, what we looked at earlier, the sensitivity of the data, and what is normal from that perspective. And if I can protect it and I can understand what is normal, Now I can, on top of it, apply principles to say, if this changes this threshold, then start alerting or start blocking or put that person in quarantine and let's figure out what they're trying to do. And so again, zero trust is a term that's used quite often, but it's more like a freeway where you trust the people who are in the freeway following the rules. And you could do spot checks once in a while here and there from an insider perspective, but ultimately you would say, if you're on the freeway, we trust you, you're following the speed limit, you're going the right direction, and you're not having erratic behavior. But if you're outside the freeway and you're not supposed to be outside, then obviously that trust boundary has been broken, right? So zero trust really comes from the perspective of being able to isolate actors that are not following the norm. And so is it possible? Yes, it's definitely possible from the perspective of being able to control what you can see or what you can give that guardrails, view of things. And then now zero trust, again, is a very fluid topic and different people have different perspectives of it. But just from the perspective of being able to control of what you are authorized somebody to do, zero trust is possible. And then thinking about visualizing data. Again, we talked about how do you look at your data structure and different aspects of it, and how do you visualize it? So we're going to have a little slide in the next one, which is going to be a busy slide, but I want you to take a few items from this slide. You think about in the cloud computing business, you have the edge layer. You've got the cloud fronts, you've got the CDNs from different providers, you've got the different areas on the edge that the data comes in. Then you have the compute, where you're having a lot of processing that is happening. And of course, the data itself, the data integrity and the confidential, the CIA triad that we commonly talk about. And of course, messaging and streaming are a very, very hot topic right now with the amount of data that can be passed through an environment. And access controls, monitoring, development. But here, there are a few key areas that you want to break your basically your infrastructure into to think about, how does my edge layer look like? Am I using a CDN? Do I have APIs? Do I have user authentication? Do I need a geolocation blocking because I have some data sovereignty rules that I have to manage? And then in the similar way, you can map out your entire data flow based on this view. You can say for messaging, what is the validity of the message? How much amount of message do I take into my backend systems? Do I filter some out? Session management and access, that's a big topic. Finding actionable events in monitoring. It's like finding a needle in a haystack if you just log all the events. But if I'm smart about what type of events that do I really want to monitor and take action on top of it, or handling errors. And also, like, some of them are outside the scope of just a technology, where open source, how do I handle open source? How do I do security awareness programs? How do I let people know how do they need to do serverless, not to give them bad actors access into our environment. And again, this is a busy slide, but just to think about the data in a serverless broken down by layers. That is crucial when you're being able to map out your infrastructure and how do you want to manage serverless security in securing the unseen. And just to group a couple of key design principles, I want to switch gears a little bit because we're going to be talking about certain application of designs in these three contexts. Right, you think about the IAM context, the identity and access management, and how do you manage identity? How do you manage access, least privilege? How do you manage defense in depth, allowing multiple layers of controls before people can get into your network? And we're going to be talking about this in this context in the slides you're going to be seeing after this. So I just wanted to kind of call that out, and we're going to jump into a sample architecture on Amazon and talk about how that applies. So here's a very typical architecture that we're going to be looking at in Amazon. You've got the content delivery, you've got messaging, and some sense of authentication and authorization, APIs. Again, event-based modeling in your events that are going to the data store. And you potentially could have a separate account that manages a lot of your DevSecOps pipeline, manages a lot of your forensics. If there's a breach, being able to take the data and move it into this other account so that you can do forensics on it. An external logging interface so that it's not tampered with. And then, of course, your security and governance are very common. Your keys, what keys do you use to manage? And what is the WAF strategy, logging, access? And we can talk about a lot of these, but I want to take a few scenarios in the subsequent slides and talk about how does it apply from the groupings that we saw in the previous slide? So here is the front-end layer. When you talk about data coming into my environment, right, where I have users hitting my endpoint and trying to access some service that I'm providing. Maybe it's a lookup service. Maybe it's something to submit claims or do certain sensitive information or entering their social security number. So you have the different defense in depth type applications that you can do or protections that you can do, like geo and IP restrictions, or using a web application firewall, or using single sign-on if it's an internal user. Again, these are all different defense in depth that can be applied when you're looking at a front-end layer. Now, again, we're still in the context of serverless, right? And we're still seeing a lot of things which we're still doing a lot of things to things that we don't see necessarily of how maybe in this case, Amazon manages their infrastructure. But what we can do is that we can have these type of patterns that will allow our developers, allow our security professionals to be able to take it and apply it in their company so that they can be secure in that sense. And then you think about a sample S3 bucket policy to be very, very specific from a least privilege principle perspective of saying only allow get object or only allow these source IPs to reach my bucket. Again, the reason why is you want to be thinking about, even though it's serverless, even though there are things that you don't see, you don't know how Amazon manages it, or Azure or Google, you're still being able to doing your part in making sure that you're following least privilege principle. You're doing these kind of protections in the front-end layer. And similarly, from a content distribution perspective, you can have things like security headers, enforcing TLS, HTTP to HTTPS redirects, and just many areas. And these are just some examples that are there. Rate-based rules are very important. Log parsing, being able to take the logs and applying, maybe enriching the logs with certain other information that you want to add on to it, and then storing into a centralized search engine. And that can be very, very important when people are trying to search for things that they feel like are an issue. And jumping into the next area of the middleware. In the middle layer, you think about areas such as token validation, standardizing inputs. We had the struts vulnerability, many other areas. Again, application being able to take to standardize the inputs. Now, we saw a demo earlier where the user allowed somebody to be able to get into a shell, a Lambda shell that they were hosting. Now, obviously, in that case, they were just doing a direct exec into that shell. But if you think about it, that really would be something like an input validation to say, what is someone trying to pass into my API gateway or however that is being invoked? And do I need to take that data, sanitize the input, make sure that the input is what I expect it to be, and then pass it on to the next step in the flow of the application. So that is very, very crucial. A lot of times people don't think about it, but that is very crucial from a protecting from an access and managing that access. And again, here's a sample JOT token. It's a simple OAuth implementation where you've got specific group names that I belong to, or what is the audience, who's the issuer, what is the expiry. And again, validating those things, and kind of along those lines, some of the best practices when dealing with JOT tokens, they are used across the board for making sure that when somebody signs in, like your Facebooks or you're signing with Google, a lot of times you will have to deal with OAuth. And JOT is just a way that they make sure that the user who they say they are is who it is. And then when they pass it on to the backend systems, they can validate it, like making sure that they are using strong algorithms and validating, making sure that it's not expired and making sure it's still the right issuer and the right audience, reducing the scope of the tokens, don't allow more than it's supposed to have. And again, this is just a simple example of how a JOT token potentially would look like. And jumping back into the architecture onto a backend layer perspective, being able to look at it on a database level, being able to keep the database within the VPC. In this example from an Amazon, obviously different cloud providers would have their own way of securing it. Again, this is a general principle you can apply to any cloud vendor. Encryption at rest, which is very common. And more than that, data level encryption. Encryption at rest is, I know a lot of times traditionally people have done that when they were thinking about data center and people, sysadmins having access to the data center to be able to protect the data. or your laptop's getting stolen. But really, data level encryption is much more important when you think about from a cloud provider perspective, is because the data centers are pretty well guarded. And you think about whether it's Google or Amazon, being able to get in, somebody trying to steal a disk and knowing which customer that is huge. That is extremely hard for somebody to be able to do that. But data and level protection, where even if they get into your system and they try to exfiltrate your data, how do you protect that data from leaving your system? Being able to do something like least privileged roles, meaning that somebody cannot log in as one user and try to do a lateral movement and see how much access does that user have within the cloud space from an IAM role perspective, and then being able to do lateral movement into another application that they're not allowed to do it. So being able to lock that down using least privileged roles, the minimalized roles, that even what we saw in the demo, it was a very, very least privileged role that had access to that Lambda function. And then again, automated containment is something that you may want to think about. If there's a breach, if there's something in my in an instance that is acting in a way that I don't expect it to, what is a quick way of being able to isolate that out of the pool of other instances? Maybe it's a tag you apply to it. It has an event-based Lambda that goes in and isolates that instance, takes a snapshot, moves it into this external account, and then takes it out of the pool, and then another server is added to the pool so that the business can continue to run, but now you automatically contained that one instance, which you're not sure what's going on, and then you can quarantine it. At that point of time, you can take it, and then you can apply it to the point where you can start doing some forensics on top of that. Again, there's many ways to do these kind of things, but you should have a plan of action. How do I secure my backend layer, where my data is protected, more than processing? At some point, it's going to rest in my backend layer. Here's a sample database policy. It gives very specifics about in DynamoDB, I can get item, and it's going to come from the source VPC. Maybe it's 2 accounts you have, 2 VPCs you have, and you're sharing data from this DynamoDB instance to this other Lambda that wants to query it. Again, you're isolating it in a very, very specific way. And we're going to talk about a couple of applications. One critical thing, from a practical application perspective is, don't boil the ocean, right? I mean, serverless is a massive field. I mean, it's a massive field because it's got so many entry points. You think about Kinesis for streams. You think about CDNs. You think about event-based processing. You think about data lakes that are even built on top of serverless technologies or managed services. If you think about that, it can be overwhelming. It can be overwhelming to look at the gamut of servers or the or the opportunities that cloud providers give us and say, man, how do I secure this? Because it's such a big footprint. So I would say don't boil the ocean in the sense that make sure you understand there are some immediate things that you can fix in your environment. There are some short-term, then there are some long-term, right? Have a strategy around your security planning when you're looking at serverless and securing the unseen. Some are, from a time-based perspective, you may say it's going to be 6 to 8 months, and that may be a long-term plan. Again, from a cloud perspective, that is a long time because they keep changing their features and advances in months or weeks, and even Amazon in many iterations per month, and so or even other providers for that matter. But you want to have a plan of saying my short term is going to be 1 to 2 weeks or 3 weeks, and then my or my immediate maybe, and then the short term maybe 3 to 4 months, and the long term maybe 4 to 6 months. Again, you may have a plan based on your company, and then the hybrid deployments again also have its own understanding. How do I secure the integration points between my cloud and my data center? Things like Direct Connect or other areas that you can think about from that protection perspective. How does data move from one environment to the other? Can my production cloud account talk to my development machines in my data center? Again, all of those things have to be taken into consideration. So along those lines, I want to again come back to this slide that we looked at prior, where we talked about data and how does data apply in all of these layers. And now I want to think about how does security apply in all of these layers. You think about, again, we looked at edge computing and data and all of these different layers in the previous slide, but we looked more from a perspective of from the lens of a data. But now we're looking at it from the lens of security. And so again, we talked about intermediate, short-term, long-term. And taking things like the edge, it's like rate limiting or managing your cache, doing something like WAF, or what is the key policy that I want to apply for API gateways. And then similar concepts with compute, making sure that there's key management when I'm dealing with moving of data that is sensitive or processing of data that's sensitive. And similarly, areas such as data itself about how do I do input sanitization? When data is coming into my environment, do I sanitize the inputs? Do I look at it, make sure this is something that I expect, or discard it, right? Or put it for forensics, or try to capture this IP is sending me a lot of bad data. I'm going to put that IP in quarantine. I'm going to talk to my edge layer and tell CloudFront to quarantine that IP for 15 minutes. And then I'm going to allow it. And if it happens again, I'm going to put it away for 6 hours or whatever it may be. So you want to have that kind of strategies planned out, for your environment. Things like token management, RBAC, role-based access controls. That's so crucial when you're dealing with serverless, because what access you give that one small entity is going to carry on for subsequent calls by that entity. So you have a Lambda function that fires an event, and you may have 1,000 Lambda functions that fires because there's files coming in all the time. And that one Lambda or the permission that's assigned to that Lambda function is going to inherit for any other Lambda that gets fired as well. And then, of course, you got global context, meaning that anytime I declare a variable in the Lambda, if it's global, the next Lambda can pick up on that variable and use it as well. So again, there's a lot of things that goes into in those areas, or even from a development perspective, being able to do CI/CD automation and some of the tools that are available for securing this type of or applying security in serverless areas as well. Again, this is just a very busy slide, but I'm hoping it'll be a help so that you can look at it more from applying security in the sense of different layers, rather than thinking of security as this one solution or one-stop shop for anywhere you want to put it in the cloud, saying, you know what, I really want to think of security as breaking it down by these different towers. And each tower has a different way I approach security in the serverless space. And that is crucial mindset that as security professionals that we have to have, or even as developers, we have to have to say, well, I'm a developer, I'm going to be writing code for processing data. Well, you have to think about, how do I sanitize my inputs? How is my data coming in? Who's checking it at the door? And you should ask those questions as well. Again, we definitely have to see this as a joint effort. That ties me into some of these final thoughts. When you think about serverless, what are you really trying to solve? We saw the first picture of that house with the most important entity in that picture was that person. That is the person we're trying to protect. That's what we're trying to solve. And serverless is a great great paradigm that the cloud has brought for us, and it gives us so much opportunities to be able to secure data, to be able to do a lot of interesting things from an architecture perspective, being able to bring in streaming data, bring in mashups, and again, there's the potential is massive. But you really want to take a step back as a security professional or trying to understand from a security perspective or a mindset to say, what am I really trying to solve? Am I really trying to solve where I'm trying to protect the data when it comes into the door, or am I trying to solve when I protect the data towards the end? Now, business wants to do something very different than what a person who's developing or a person who's a security wants to do. The business may say that, hey, I want them to have the most easy experience from a user experience perspective. They get in, they click it, they get a magic link, they go and do their stuff. But the security professional would be like, well, that is risky, and that's not something what we want to do. So again, you want to have a middle ground where you say, what compensating controls do I have if the business wants to go this route? And again, I'm here to support the business, but also making sure that I can give them and align them to certain controls that will protect us as a company. And so that is very crucial. What are you trying to solve? And again, here, this is a very familiar topic about the shared security model, where the public providers say, hey, we will manage the infrastructure that your stuff sits on, that your data sits on, or your processing happens. That is our responsibility. We'll protect the data center. We'll make sure there's cooling, there's backup systems, there's UPS, and making sure that it's secure. Your data is not going to bleed into another customer's data. We're going to make sure that all of that bottom line is protected. But anything is secured. And on top of that, everything is on us, right? So if you put in data and somebody puts an S3 bucket and they click it as public and then there's a breach, Amazon is not going to come and saying, well, oh, sorry, we shouldn't have done that. But that's really a customer engagement. That's really how the customer is engaged by using that cloud provider and made it publicly exposed. And that really comes under our responsibility, right? That's not the responsibility of the provider. It's the responsibility of the user or the company that's using that service. And DevOps engagement is crucial. It's not a matter of like, okay, we're a gate as a security professional, let developers come after they're done. No, we have to get from the ground up. We have to look at that data in those layers. We have to look at it from the perspective of how do I help the developers, educate them and help them to be security aware and be part of their sprint cycle. I mean, that's something that we're seeing that evolution of the security mindset into DevSecOps and multiple other initiatives, where we really need to plug ourselves into a sprint cycle to say, hey, what are you working on? What are some things that can have an implication on security? And what are some things that I can do to help you be successful so that you're not trying to go out the door and then security comes and says, oh, you shouldn't have done this, right? So that is a very bad taste people get when that kind of an engagement is there, a lot of friction, a lot of challenges, but really need to have DevOps engagement that is very, very crucial in this scenario, not only for securing it, but also education and making people aware of those type of layers and different ways of addressing it. Again, we looked at this security in serverless is based on a threat. What is the threat? Am I in the edge layer? The threat is higher. Am I in the backend? The threat is there, but it's a different type of threat, right? It's not necessarily lower because you're protecting data, and those can be very sensitive data, but the threat is there, but it's a different type of threat, maybe more of an insider threat, more of an accidental exfiltration, or other methods where if somebody gets into the door, if they get there, then obviously it's a much more critical risk at that point of time. So it's based on a threat factor. And finally, I just want to leave you all with this quote. Serverless security is about anticipating the journey more than reaching a goal. We're not trying to get to a goal, right? You can say, hey, I'm secure. Well, Amazon just released a new product, or Google just released a new feature, or Azure released a new service, and we're back to square one. No, you have to really think about serverless security is anticipating the journey. You're looking at it and saying, hey, here's where I am, and here's where I can improve, and I'm constantly iterating on that thought process, right? You're anticipating the journey more than trying to reach a goal, right? It's a process, and it's a strategy that you want to have in all of the stuff that we've talked about that can help you get to that end state of being able to have a plan of being secure in securing the in the serverless world. And with that, I would really love to again have a conversation, and really thank you for listening in this topic about serverless security, and looking forward to hearing some questions. And if you have any questions, be glad to answer that as well. Thank you.